Hello again. As you know, I am Eli, the computer guy, and today's class is Introduction to Solid-State Drives. So solid-state drives are one of the greatest things since sliced bread for computer hardware. Solid-state drives are really just amazing things. And if you are not using a solid-state drive in your PC right now, you should really think about doing it. Now, when we talk about computers, when we talk about servers, the big thing that we always talk about from a technician's point of view is where is the bottleneck? The bottleneck is the slowest point in the computer, the slowest component in the computer, which then slows down the entire computer. Now, a lot of new people in computers and servers, whenever they're thinking about the speed of their PC or the speed of their server, they're thinking about the CPU, they're thinking about the RAM, they're thinking about the graphics card, they're thinking if I have a bigger, better, faster CPU, if I have more RAM, if I have a massive graphics card, my computer is going to run amazingly well. And ironically, the one thing that many people usually completely overlook is the hard drive. And honestly, truly, the hard drive is usually the biggest bottleneck on your computer. The hard drive is the one place where everything slows down. You can have 100 gigs of RAM in your computer, you can have an i7 whatever core processor, and if you're not using a fast hard drive, your entire computer is going to just chug along. So what are solid-state hard drives? So normal hard drives have a platter, basically like a record or a CD, inside a case that spins around, and then there's a little arm that reads and writes to the platter, so that there's moving components in a normal hard drive. In solid-state drives, they use what is called NAND flash memory. So NAND flash memory is what is called non-volatile memory. So the normal RAM that you are used to using, DDR123 RAM, is what is called volatile memory. What volatile memory means is that it only is able to store information when there is an electrical charge going to the memory. So as long as there is electricity going to that memory, it is able to hold the information. As soon as the electricity is cut off, though, all the information is lost. Well, with NAND flash memory, this is non-volatile memory. What that means is when the power is cut off, that the memory stays in whatever state it was when the power was there, so either in the off and on. So basically that is why these solid-state drives are able to keep information, whereas normal RAM, when you reboot the system, it just flushes all the stuff out. So since we're using this NAND flash memory, that gives us a lot of benefits over normal hard drives. Now the first thing that always comes up is speed. So generally, we're going to talk about this a little bit more in a minute, generally solid-state drives are much faster than other types of hard drives. If you compare a solid-state drive compared to a 5400 RPM hard drive, it is going to be much faster. Compared to a 7200, it's going to be faster. Compared to a 10,000 RPM drive, it's going to be faster. Compared to the SCSI 15,000 RPM drives, it depends on what solid-state drive you're using. But generally, and this is one thing you should think about, generally the solid-state drives are going to be faster than the standard platter type hard drives. Beyond being faster, one of the nice things with these solid-state drives is they use less power. So they actually draw less electricity. Now I know when you hear something like, oh wow, solid-state drives draw less electricity, most computer geeks are kind of going whoopee crap. It's nice, right? That's cool and all ecological, but really who the hell cares? Well, one of the reasons that you need to keep this in mind as a modern technology professional is remember, electricity rates are going up and up and up and up and up, right? Electricity is starting to cost real money. It's just like gasoline. Remember, when I was in high school, gasoline was 99 cents a gallon and nobody cared. Now that's $4 a gallon. People start thinking about where they're driving. Same thing with electricity. Electricity used to be dirt cheap. Here in the Baltimore area, it keeps going up and up and up and up. Now, when you're thinking about the electricity usage of a single hard drive, that doesn't seem like a lot of energy or monetary savings. You know, if you're just thinking about the hard drives in your house and you swap from a platter type hard drive to a solid state hard drive, okay, you're saving a little energy, which obviously means you're saving a little money over the year, but again, who really cares? Why this is important, and you guys should be thinking about this, is because in the enterprise environment, when you have hundreds or thousands of computers running basically 24 hours a day, that little bit of energy, that little bit of monetary savings can really start to add up. So that's one of the things that you guys should be thinking about, again, as modern technology professionals. Beyond they're fast, beyond the energy efficiency. Again, since they have no moving parts, they are very quiet. They're essentially silent. And since there are no moving parts in there, one of the nice things with them is that they resist damage due to vibration. Now, when you're dealing with a normal hard drive, right? A normal hard drive has those platters in there spinning at 5,400, 7,200, 10,000, 15,000 RPM per second. They're whizzing around, right? Like a record. And you've got an arm in there reading and writing. Now imagine when those platters are moving around and that arm is moving, imagine if you hit that hard drive. Imagine if you tap your PC the wrong way, or imagine if you're shutting your laptop, so you close your laptop and it's in the process of hibernating, and then you throw it into your little briefcase and it knocks, right? Well, that arm zipping up and down, up and down, up and down, up, you give it that extra impact and then it bends, and now you've destroyed your hard drive. Since these SSD drives don't have any moving parts in them, you don't have to worry about that type of vibration. Also, the good part with the solid state drives is they run relatively cool. So this can be a real benefit if you are dealing with environments that get very hot and you don't want to add additional heat because of your computing equipment. The solid state drives actually run relatively cool. So when you're thinking about getting these solid state drives, there's one thing that comes up, and this always comes up with people, and they go, Eli, but don't solid state drives wear out? Which is a good point. There's something called memory wear. So with these solid state drives, because of this NAND flash memory, this was more prevalent a few years ago, but it still exists. Basically, the more the memory is used, the memory does in fact wear out over time. There's now special algorithms and software built into these hard drives to try to prevent that. But the reality is that solid state drives do wear out through normal usage over time. This is true, but again, for most of you, it is not going to matter. If you use your computer day in, day out as an average user, your solid state drive is probably going to last 10 years, which frankly is going to be a lot longer than you're probably going to own your computer. So I have my computer back here that I built a little over 4 years ago with its Intel solid state drive in it, and it's chugging along just fine. When the memory wear becomes a real problem, frankly, this computer is going to be gone regardless. Now, the one place, and again, when we're talking about being a real technician, we're talking about being a technician in the real world, remember, we always have to be thinking situationally, right? So if you are the average user, the hard drive is going to be long gone before it wears out. If you're putting this into the average server, so some small business server in a small office with 20 users, again, that server is going to be long gone before that hard drive wears out. But this is a real issue if this is going into something like a data center environment. So if you take that same solid state drive and you plug it into a server that runs Travelocity, or a server that runs Facebook, or a server that is continually getting hammered every second of the day, then that is the one place where you may have to concern yourself with memory wear. Now, this is one of those things that, depending on what hard drive you buy, from what manufacturer or what model number, they have lots of different stuff about memory wear. So all you really have to remember is if you're the average user, frankly, don't worry about it. If you're the average business user, frankly, don't worry about it. If you're working for Facebook, then you should worry about it. Honestly, when you look at the stats, I was looking at the stats, what's called the mean time between failures, between normal hard drives and solid state hard drives, honestly, solid state hard drives generally last twice as long as normal platter based hard drives. So again, memory wear is there, but most of the time you don't really have to worry about it. Now, one of the big things because of memory wear is that you don't want to do something called defragging your hard drive. So defragging, you know, everybody in the world, especially new computer technicians, everybody wants to defrag. I don't get what it is. Everybody wants to defragment hard drives. The one thing, again, if you're dealing with platter hard drives, I would suggest not worrying about it because it's going to take you like 5 days to defrag a 3 terabyte platter hard drive. But because of the memory wear issue, you don't want to defragment solid state drives, because when you do the defragmenting, it moves all of that data around, and every time data gets moved around on a disk, it does wear out that memory. So in general, you don't want to defrag your solid state drives. If you do it once or twice, it's not really going to help anything, but you're not going to kill your computer either. But basically, in general, just don't defragment solid state drives. There is one thing called trim. So you do want to trim your solid state drive every once in a while. Think of it as the defrag for solid state drives. Basically, it gets a little confusing, but how data is stored on these solid state drives, it's stored in blocks. And in order for the computer to actually interact with any data in the block, all the information in the block has to get pulled off. It gets a little complicated, but basically understand that every once in a while you should do something called trim your solid state drive. It is the equivalent, same but different, of defragmenting your drive. Now, if you're dealing with a modern Windows operating system, Windows 7, Windows 8, it automatically trims your solid state drive for you. If you're dealing with Vista or XP, you may have to download and install a special application from whatever vendor you purchased your solid state drive from, Intel or Crucial or any of these. Basically, you can download an app and be able to futz with it that way. So that's the basic idea with it, these solid state drives. They're faster, they're cooler, generally they are better. But the one thing that you have to realize when you are dealing with anything in the computer world is you do actually have to look at what you are purchasing, because many times things that look identical can be very, very, very different. So the first thing to understand, right, is that these solid state drives are built with NAND flash memory. This is non-volatile memory. So that's the memory part. Depending on how that memory is functionally built, depends on how fast that memory is. So different types of memory are going to be faster or slower. Just like with a normal hard drive, where you can buy a 5400 RPM, which is slower than a 7200, which is slower than a 10,000, which is slower than a 15,000. Same is true in the solid state drive realm. Different drive material is either faster or slower than other material. And we're going to show you that in a second. The other thing that you have to think about when you're dealing with solid state drives is, just like everything else, you have to think about bottlenecks, and it's the interface for the solid state drive. So you can connect a solid state drive to your computer in many ways. So normally, the normal way everybody does now is SATA, so SATA 3. But your hard drive, your motherboard could also have SATA 2 or SATA 1. Remember, those have different transfer speeds. You can also connect, and if you're in the, so normally you're going to be connecting with SATA 3, and that has its speed. If you're in the enterprise world, or if you have some extra money, like me, because I'm thinking about buying one, you can buy a PCI Express SSD card. So what this is it's an SSD drive that you actually plug into the PCI Express port on your motherboard. This is going to be the absolute fastest interface of any of these hard drives. If you're looking for the absolute fastest drive that you can put into your computer, you're going to be wanting a PCI Express SSD drive. That's going to be the fastest, because the material, the NAND flash memory is going to be fastest, and the connection to your motherboard is going to be fastest. So you've got SATA, you've got PCIe, you also can get IDE solid state drives, and even, as you know, little flash thumb USB drives. Now you may be thinking, well, that stuff's old. Why would I want an IDE drive, or even be using a flash, a little thumb drive in order to run my computer? Well, again, as modern technologists, we need to be thinking about computers beyond the idea of Windows 7, Windows 8, Server 2012. We got to be thinking about all the places we could put computers and all the things we could do with computers. So if you're creating something like an embedded system, so an embedded system is where basically when the computer boots up, the entire operating system and all the applications get loaded into RAM and run from RAM. So like surveillance systems many times will be embedded systems, car audio systems will be embedded systems. For things like that, you may want to use something like an IDE drive or even a flash drive. Now the interface is really crappy ass slow, but they are inexpensive, they are robust, and if the only time you're going to interact with them is whenever that computer boots, that may be okay with you. So those are the different interfaces. So now when you're thinking, one of the questions that came up is somebody said to me, I did a class on hard drive, on determining hard drive speed. And somebody said to me, Eli, I don't understand, because when you showed us your SSD drive speed, it was really fast, and then they ran the same test on their SSD, and it was really slow. It was like, I think it was almost slower than my old platter drive that I have on my computer. So that is where you have to understand the other speeds, things that you have to look at with your SSD drive. So the first thing that you have to look at is IOPS. IOPS. This is input-output operations per second. This is very important. This is how many individual transactions can be pushed and pulled from the hard drive at any one time. Now normally, you know, for most of us, this isn't a big deal because we don't actually do a whole lot of input-output operations per second. So normally we're pulling, let's say, a movie file to look at. We're pulling emails. We need to be able to pull the data quickly, but each individual transaction, it's very few transactions. Why IOPS is important is for when you're dealing with something like a database server. Imagine a database server. All the information that's pushed and pulled to that database server is very small, just text or integers or characters, but it's getting pushed and pulled a lot per second. There's a zillion transactions per second. So that's where IOPS can be very important. Then you have what is called the sequential read and the sequential write speed. So the sequential read and the sequential write speed means if you're dealing with one big file, what's the fastest that can be pulled off, read from the hard drive or put onto the hard drive? So one sequential file. So if you're dealing with, let's say, a high-def movie that's 3 gigs in size, if you're pulling that movie off or you're interacting with that movie, how fast can you interact with that movie? The other speed that you have to look at is what's called random read and writes. So when you're dealing with numerous different files spread all over the hard drive or the drive, how quickly can it go and get all of these random files at the same time? So those are the 3 things. Once you figured out the interface, those are the 3 things you have to look at for the drive itself. The IOPS, input-output operations per second, the max sequential read-write speed, and the max random read-write speed. So let's go over to the computer now, just so I can show you. I have Newegg up, so I can kind of show you what to look for when you are going to be buying one of these solid state drives. So basically we have here, and we can see we have like 3 Intel drives. So as you can see with this one, this is that PCI Express drive. So it doesn't look like the normal hard drive you're used to. It looks like just an expansion card, but this is what you would be dealing with. So basically we've got 3 here. So we've got this one, the 910 series 400 gig, then the 910 series 800 gig, and then the Intel 335, and this is the normal hard drive. So this is, as it says here, a SATA 3 hard drive. Now the first thing that you're going to notice is cost. Holy bejesus. I don't know if you said that, but that was the first thing that came through my mind when I was seeing these costs. So I like this down here with this nice little SATA hard drive, solid state drive, 104 bucks. That's right within my budget. It's a little small, it's only 80 gigs, but $104, I'm not gonna cry over that, right? But if we go up here to these PCI Express solid state drives, we can see this one up here is $2,000 and this other one is $4,000 for an 800 gig drive. Wow, that's expensive. But when we see that price, then we have to go and we have to start looking at the performance difference between these drives. So this nice little $104 drive down here, if we look at the random read writes, we can see up to 15,000 input-output operations per second. If we go up here, we can see that with the 400 gig PCIe Express drive, it's 90,000. And then if you go to the 800 gig version, it's 180,000. So this thing right here for the input-output operations per second is going to be something like 13 times faster than this little 335 series down here. So that's one of the things you have to think about. Again, random write, we're looking at 25,000 input-output operations per second. Here it's 38,000, and for the most expensive drive, it's 75,000. Then we can go down here and we can look at the max sequential read write. For this particular one, it's 1 gig per second read, up to 0.75 gigs per second write. And if you go down here, you can see it's up to 2 gigs per second read and 1 gig per second write. So these are the different performance metrics that you need to be looking at the solid state drive to determine which one you want to buy. Again, you know, the difference between $104 and $2,000 or $4,000 seems like a lot, and it seems ridiculous until you start looking at these numbers. If you figure this SATA solid state drive is probably going to be twice as fast as a normal hard drive, and then you figure this thing right here is going to be 10 times as fast as this, you get what I'm saying? This is going to be a very, 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 very fast drive. So depending on what you're doing, you may want to buy this. The other thing to remember, and this is very, very important, especially if you're going to be buying these PCI Express drives, is again to look at the performance for whatever drive you're looking at. Because at the end of the day, I in fact may be buying this particular drive right here. And the reason is I want a PCI Express drive. And so I first looked and I saw this one was 800 gigs, $4,000. And I'm like, oh, I don't want to spend $4,000, just like you. No, I don't want to. And so then I looked, and it's the exact same series, and I went, well, 400 gigs, because I do all this video editing, 400 gigs is more than enough for me, and it's only $2,000, so it's half the price. So maybe I will go with the $2,000 version instead. It's still expensive, but I can stomach that. I can stomach that a hell of a lot easier than I can stomach the $4,000. But then, when you go down, what you're thinking is that it's half the price because it's simply a smaller drive. But not only is it a smaller drive, again, if you look here, the actual performance is like half of what this more expensive drive is. So not only does the more expensive drive have more storage to it, but it also, in fact, actually has much better performance. So that's going to be one of the things that you need to be thinking about when you're going to be buying one of these drives. It's like, what you decide is what you decide, but yeah. The other thing that you should realize with these particular, when you're dealing with the PCIe solid state drives, is one of the things that always comes up is people always talk about the boot speed. So how much faster their PC boots up now that they have a solid state drive. Well, if you use a SATA drive or if you use an IDE solid state drive, you don't have to worry about any fancy configurations. Basically, you just plug it in and it will work like a normal drive. One of the things you do have to be concerned about, though, when you are dealing with these PCI Express drives, is some of them are seen as RAID cards to your BIOS. So if you've ever dealt with a RAID card in your computer, you know that the computer basically, it goes through its normal post routine, and then if a RAID card is detected, it then has to go through a RAID post routine, which in fact slows down the boot time of the computer. Once the computer is booted up, it will be really, really, really fast. But if it has to slow down for that RAID post, then it's going to slow down for a while. So basically, you know, instead of having a 30-second boot time or whatever, you're probably going to have about a 2-minute boot time. So one of the things to look at, and I think they say it here, is whether there's any hardware or software configuration for the solid state drive. So one of the reasons why I like the Intel drives is they make things a lot easier for you. So for this PCI Express drive, basically you can just plug it in and it will simply work. I don't have to worry about RAID configurations. I don't have to worry about the drive being detected as a RAID controller or any of that mess. I can just plug this PCI Express card in and it will look like a hard drive, and away I go. But this is something, especially with the lower cost PCI Express cards and other specialized ones, make sure, is it seen as a RAID card or is it seen just as its own basically hard drive? So that's what we're looking at when we are dealing with solid state drives. So again, solid state drives are really, really amazing. I've got 3 solid state drives and they're great. Like I say, I have an Intel solid state drive in this. I've had for like 4 years. I just got 2 new solid state drives. One, as I say, I have a brand new Asus computer desktop that I purchased just for doing lab work, and I bought it about 3 months ago. Seriously. i7 processor, 16 gigs of RAM, all the fancy, you know, good graphics card, the whole 9 yards. Let me tell you, putting a solid state drive into that brand new Asus computer, literally, it may not have doubled the speed, but it was pretty close. So that's one thing, I mean, really and truly think about with solid state drives, is that solid state drives are an inexpensive way, generally, to make older computers run a lot faster. And one of the big things to remember is for a long time with hard drives, we were always looking at space. We want more space, more space, more space. You know, I want 20 gigs, 80 gigs, 100 gigs, 500 gigs, a terabyte, 3 terabytes. Now, what you should be thinking about, though, is that in the real business environment, especially in the real enterprise environments, right? You're not dealing with things like iTunes. You're not dealing with things like movie files, right? So most average office workers are actually taking up about the same amount of data storage space that they were almost 10 years ago. They're probably taking up 20 or 30 gigs of storage. So they may have a 500 gig hard drive in their computer, but they're not really using very much of it. So if you go in there and you give them a 120 gig solid state drive, it may be smaller, but it will run a lot faster. And so it may make everybody's life a lot easier and a lot happier. And again, you know, right now we're in this cost-cutting mode. We used to have refresh cycles that were in every 3 to 5 years. So a refresh cycle is where you go in and basically replace every computer in a company every 3 to 5 years. Well, now, you know, companies don't have nearly as much money as they used to. They're looking at and they're thinking, do I really want to replace 1,000 computers with brand new ones? So they may not want to replace 1,000 computers with brand new ones, but if you can go in, you can say, I can buy solid state drives for $150 a piece and do my labor. So let's say a migration would be like $250 to $300 per computer. For $300, you can have a computer that will run faster, be more stable, use less energy, so on and so forth, versus buying a new computer that'll cost you $1,000. That might be a good selling point for you. So, as you know, I'm Eli the Computer Guy. This class was Introduction to Solid State Drives. As always, I enjoyed teaching it, and I look forward to seeing you at the next one.